Hello everyone and welcome to the new video. In this video, we are going to discuss a question that came in ESE 1997 for 10 marks. So the question is, as we can see here, it is written like a cylindrical piece of steel 80 mm diameter and 120 mm long is subjected to an axial compressive force of 50,000 kg. Calculate the change in the volume of the piece if bulk modulus is equal to 1.7 into 10 to the power 6 kg per centimeter square and Poisson's ratio is 0.3. So, let's see what they are asking us to get. They are asking us to calculate the change in the volume. They are asking us to calculate the change in the volume. Okay. See, here I have mentioned this is a piece which is piece of steel which is having 120 mm length and the dia is exactly 80 mm. Okay, now if we see, they have given that a 50,000 kg compressive force, the force nature is compressive. So 50,000 kg compressive force is applied on the object like this here and like this here. This amount is 50,000 kg. Okay, we have to calculate the change in the volume. So for calculating the change, see, so here there will be some concepts that we will discuss. The very first is the change in the volume upon total volume is nothing but it is known as strain, right? So change in volume, see, whenever there is a load, whether it is compressive or it is tensile load, these types, or bending, any load we can say, these loads will change the shape, will change the volume, right? For example, if I take any elastic rubber band, for example, so if I stretch that rubber band, there will be increment into the length of the rubber band, but we all notice that there is a decrement in the cross sectional area of the rubber band. That means if the longitudinal axis is x-axis and the cross sectional axis will definitely be in y and z axis, right? So there will be changes in y and z axis if there is a change in we say x-axis. And another thing, if there is a positive change in x-axis, that means if there is increment in the length, there will be decrement in the y-axis and z-axis, because total volume should be the same, right? So that is the concept, total volume should be the same, but how much we can say how much the dimensions will change, that depends on this. For example, so here it is del v upon v, that is change in volume upon total volume, and this is known as strain in the object. So total strain we can say it as del v. So total strain will include of strain in x-axis plus strain in y-axis plus strain in z-axis. Okay, so if we calculate see, the total volume we are having, we have the dia and we have the length, we can calculate this total volume, right? And this change in volume we will calculate by this formula. We have total volume, we will calculate the epsilon x, epsilon y and epsilon z, and we will get the change in volume. So there is a formula. See, this is also a formula, and this is we can say this is a concept that we should know. Now, what is epsilon x? See, epsilon is what? Strain, right? Strain is nothing but stress upon modulus of elasticity. This concept works if there is a single axis strain, we can say, if there is the total strain in x-axis, if I want to calculate, that will nothing be but sigma in x-axis, that means stress in x-axis, divided by modulus of elasticity. But do we really think that there will not be any stress in y-axis and z-axis? No, definitely not. So for that case, we have something called Poisson's ratio. This is given in the question, that is 0.3. The Poisson's ratio is nothing but minus of longitudinal strain upon lateral strain. Right, this Poisson's ratio we will use here, and see, Poisson's ratio is minus, and see the strain, if positive in x-axis, I have already told that it will be negative in y and z-axis. So minus this Poisson's ratio, actually this Poisson's ratio does nothing but relates the longitudinal strain to the you can say lateral, that is y or z. So longitudinal strain, and then we can say mu into sigma y divided by E. And similarly, there will be negative strain, that will be sigma z upon E. Okay, this is the formula for epsilon x. That's the thing. Similarly, we can write epsilon y is sigma y upon E minus mu sigma x upon E minus mu sigma z upon E. Okay, now similarly we can write epsilon z is sigma z upon E minus mu sigma x upon E minus mu sigma y upon E. This is the case, right? Now these are the three formulas that we can understand the concept, and we can just we don't have to remember this or learn this, but if we know the concept, we can write the formulas, right? Another simple idea is to learn these formulas. Now, so for calculating this, say epsilon x, epsilon y and epsilon z, we need to have sigma x, sigma y and sigma z, and E and E as well, right? In this question they didn't give the E. So for calculating E, that is modulus of elasticity, they have given bulk modulus, that is K, and from this we will calculate E. There is a relation. That relation is E is equal to 3K 1 minus 2 mu. We have given Poisson's ratio and bulk modulus. This thing relates E and K as well, that Poisson's ratio. Okay, this is a formula that we should also remember. So E is equal to 3K plus 3K into 1 minus 2 mu. Let's calculate E. That is 3. K is nothing but 1.7 into 10 to the power 6. 1 minus 2 times of what is the Poisson's ratio? 0.3. So we get the answer as 3 into 1.7. So the answer I have written already, that is 2.04 into 10 to the power 6. The unit will be kg per centimeter cube. This is the modulus of elasticity we got for steel. Okay, now modulus of elasticity we got, and what is sigma x? Sigma x is nothing but force in x direction divided by area, cross-sectional area. Force is 50,000 kg and area is pi by 4 into 80. This is written as 80 mm and everything is going to be in centimeter, so I will write it as 8 centimeter so square. So I got the answer in 5000 upon pi by 4 8 square, that is equal to 995.2 kg per centimeter square. And another thing, see, whenever there is a tensile force, we take the stress as positive stress, and whenever there is compressive force, we take the stress as negative stress. So the stress will be negative. I got sigma x value as minus 995.2 kg per centimeter square. Let's and see, sigma y and sigma z will be 0 because there is no force acting on the body in y direction and z direction. So the sigma y and sigma z is 0. Now I have E, I have sigma x, I can calculate all the three strains. Sigma x, epsilon x is equal to sigma x, that is minus 995.2 divided by 2.04 into 10 to the power 6, and it comes as minus 4.878 into 10 to the power minus 4. This is the value of epsilon x. And as we can see, the load was compressive. So for compressive load, the dimension in the longitudinal direction or the direction of the force is going to be reduced. So we got negative sign here. That means the dimension is going to be reduced. Okay, epsilon x is this. Epsilon y, in the formula, see other things are 0. Sigma y 0, sigma z 0. Here sigma y 0, sigma z 0. We got minus mu sigma x, and that is nothing but minus plus. So it formula is minus mu sigma x upon E, and that is 995.2 into mu is 0.3 divided by 2.04 into 10 to the power minus 6. That is equal to, I have calculated, it is 1.46 into 10 to the power minus 4. And the similar value will be for epsilon z also, 1.46 into 10 to the power minus 4. And as you can see, the answers are positive. That means while in compression, the lateral dimension will increase, the longitudinal dimension will decrease. So the lateral strain will increase, right? So that this is positive. Now del V upon V is nothing but epsilon x plus epsilon y plus epsilon z. So del V, change in volume, is nothing but epsilon x is minus 4.878 to 10 to the power minus 4. I will take 10 to the power minus 4 common, and plus 2 times of 1.46, so into 10 to the power minus 4, and into the total volume will be it is pi by 4 8 square plus sorry, it is volume now, right? So 120 mm means 12 centimeter. So the total volume will be, I have already calculated, that is I can directly write it pi by 4 into 8 square into 12. So the change in volume will be in total it will be minus 0.1176 centimeter cube. So see here, with the force, with the applied compressive force, there is the change in volume, that is negative, and the value is 0.1176 centimeter cube. So these are the basic concepts of strength of material. So here we have studied some concepts of strength of material topic. I hope you have understood this. Let's meet in next video. Thank you.